Okay, so we've all seen the incredible magic of AI-generated video, right? You type in a few words, and poof, whole new worlds come to life. But there's a problem, a kind of glitch in the matrix that makes these amazing creations feel, well, just a little bit off, a bit wobbly. Today, we're going to pull back the curtain and look at how researchers are fixing that exact reality-breaking issue. Just look at this. On the one hand, you've got the promise, a gorgeous, stable shot of a snowboarder that looks completely real. It's amazing. But on the other hand, you get this, the problem. The exact same AI tech can spit out this warped, jittery mess where the world just kind of falls apart at the seams. So what gives? That's the big question, isn't it? How can this same incredibly powerful AI create both absolute magic and a total mess? Well, let's dive in and figure it out.
All right, Section 1, the AI video revolution. And honestly, revolution is the right word for it. We are living through this crazy explosion in AI video. I mean, the quality has just skyrocketed lately. We've gone from these short, kind of blurry clips to footage that is, for real, photorealistic. I mean, just look at this frame. That's not a real person. That's not a real drone shot. An AI made this entire scene just from a few words of text. The detail, the motion, it's absolutely breathtaking. And, this is the magic, right? This is what makes those wobbly flaws we're going to get into so jarring.
So now we get to the flip side, a wobbly digital world. Because here's the catch. For all their amazing power, these AI models, they don't really get our physical world. They lack a fundamental understanding of it. And that leads to this weird, wobbly, unstable feeling. And believe it or not, there's a technical name for this. It's called geometric inconsistency. And that's just a fancy way of saying the AI basically forgets the rules of 3D space. It's like it doesn't understand that a tree is a solid thing, or that a camera is supposed to move smoothly, not just teleport and jitter all over the place. It fails the basic physics test.
And this is what that looks like. It's just melty. You see how the rocks are warping, the ground is shifting, it's like the world is literally falling apart. The whole illusion of reality is just shattered instantly.
Here is another great example with the snowboarder. Just watch the camera. See that sudden jitter? And look at the trees in the background. They start to stretch and distort. Solid objects just stop being solid. This right here, this is the exact problem that researchers at Google decided they had to fix.
Okay, so on to our next section. The search for stability. Now, researchers have been trying to solve this for a while, but the first attempts were, let's just say, a little clumsy. Kind of like using a sledgehammer to crack a nut. They were either way too restrictive or just painfully slow.
So basically, there were two old brute force fixes. The first idea was to just rebuild the AI's brain. Add all these new complicated parts to force it to understand geometry. And it kind of worked, but the big downside was it could really stifle the AI's creativity. The other idea was to just let the AI make the whole video and then go back and check for mistakes. And as you can probably guess, that is just incredibly slow, super inefficient. Which brings us to the breakthrough. A much, much smarter solution from the folks at Google Research. It's called VGRPO, and its approach is just so much more elegant. In their own words, the researchers call it an efficient and flexible approach to world-consistent video generation. And the key takeaway here is that instead of rebuilding the whole AI or checking its homework after it's done, VGGRPO is all about teaching the AI to get it right from the very start.
And the way it does this is just genius. It's a simple two-part strategy. First, it works on the AI's blueprint, the plan, before anything is actually built. And second, it teaches the AI the rules with a clever reward system. So let's break down exactly what that means. Okay, this blueprint analogy is the perfect way to think about it. The old way of doing things was like building a whole entire house and only then noticing a wall is crooked and having to tear it all down. Total nightmare. VGRPO, on the other hand, is like a smart architect who looks at the blueprint, spots the mistake right there on the paper, and just fixes it with an eraser. It saves a ton of time and work. So this blueprint space, that's what the engineers call the latent space. It's like the AI's imagination. And what VGGPO does is it adds this little thing called a latent geometry model. Think of it like a tiny super-fast consultant. It lets the main video AI turn to this 3D physics expert and ask, hey, does this idea I have make sense in the real world? And it does all of this inside its own head before a single pixel is ever drawn.
Okay, the second piece of the puzzle is teaching the AI with these smart rewards. It's kind of like training a dog, but for physics. First, there's a camera smoothness reward. Basically, it penalizes the AI anytime the camera gets jittery, teaching it to be a nice, steady camera operator. Then you have the geometry consistency reward. This one teaches the AI that, hey, if you draw a rock from this angle, it needs to look like the same solid rock when the camera moves over here. No more melty objects.
So what does this all mean for the final product? The big question is, does it actually work? Well, let's take a look because the results are, honestly, they're staggering. Okay, remember our snowboarder? On the left, that's the baseline AI. It's fine, I guess, but you can see that classic wobble we've been talking about. Now look at the right. That's with VGGRP. The camera movement is just buttery smooth. The world feels solid. It feels real. I mean, the difference is just night and day.
And let's look at one more. On the left, the baseline model gives us that same melty, distorted world we saw before. But the VGRPWO version on the right, it's completely grounded in reality. The rocks don't move, the vehicle feels like it has weight. It's a world you can actually believe exists.
But why is it so much better? What's the secret sauce? It's because the AI isn't just imitating what a 3D world looks like anymore. It's not just guessing. For the first time, it's actually building an internal map. It truly understands the space.
And here it is. This is the proof. We're literally looking at the AI's thoughts. This is a 3D point cloud, a complete, coherent map of the whole scene. It knows where the snowboarder is. It knows the slope of the mountain. It knows where every tree is. And because it has this solid, stable model on the inside, the video it spits out on the outside is just as stable.
And that really brings us to the big picture here. This isn't just about making cooler-looking videos. This is about teaching an AI the fundamental laws of physics, the rules of our reality. So the real question this leaves us with is a big one. If an AI can actually learn the laws of physics in 3D space, what kind of world is it going to build for us next?